Let's solve this triangle. So first we identify the type of this triangle. We can clearly see that we have this little square over here. So whenever we have this little square, we know that it is a right triangle. And also we see this tick marks over here as well as over here. And this means these two sides are congruent. So we can say that the side OU is congruent to the side length UR. And this means this is a right triangle as well as two legs are congruent. So when this happens, we see that this is an isosceles right triangle. So in any isosceles right triangle, the two legs are congruent. As we already indicated, the two legs are congruent. Here, the two legs indicated by OU and UR, which is X, is one of the legs, and therefore X is equal to Y. So first we have this relation X equals Y. Now let's apply the Pythagorean theorem, which says that sum of the squares of two legs is equals the square of the hypotenuse. So here OU and UR are the two legs. So I'm going to take the sum of their squares. That is OU is one leg. We take the square of this, and then UR is another leg. We take the square of this, and this equals the square of the hypotenuse. The hypotenuse here is OR. So it is OR quantity square. Now let's substitute the corresponding letters or the variables represented by the side lengths. OU is represented by X, so this becomes X squared, and UR is represented by Y, so this becomes Y squared, and this equals, we know that OR is 36, so it is 36 squared. Now we will use this relation which we have found out from this diagram. Since it is an isosceles right triangle, we found this relation, that is x equal to y. So in this equation, I'm going to replace x by y, or I can replace y by x. So preferably I replace y by x here. So therefore this will become x squared plus, if you replace y by x, this will become x squared, and this equals 36 squared. Now let's evaluate this. X squared plus x squared, these two are like terms, so this becomes 2x squared, and this equals, we can calculate the 36 square using the calculator. This is 1296. Now I want to solve by x itself. So first let me divide both sides by 2. When I do that, I get like this. So here I can cancel this 2 as well as this 2, and so I get x squared, and this equals 1296 divided by 2. So this equals 648. Now we want to have only x. So we have to take square root on both sides. So we take square root. So therefore here we get x. And this equals, you can take the square root of this using the calculator. And so we get x is approximately equal to 25.46. This is rounded to two decimal places. This is 25.46. So, or else we can also find its square root like this. That is the square root of 648. Now I can factor this as 81 times of 8. So therefore this equals square root of 81 times square root of 8. We know square root of 81 is 9, and square root of 8, I can write down this as square root of 4 times square root of 2. So this equals square root of 9. Square root of 4 is 2, and square root of 2, we write down this as it is. So it's basically 9 times 2 is 18. So it is 18 root 2. So if you do not want to express this in terms of decimal, it is equivalent to 18 root 2. We can say that this is a sort of exact value of x. So either x is 18 root 2 or 25.46 in terms of decimals. So we know that this value of x, since we have to solve this triangle, we have to determine the value of y. We already know that we have a relation between x and y, which equals x equal to y or y equal to x. So therefore, we see that y is also 18 root 2, or in terms of decimal, it is 25.46. Let's solve this triangle. So here we see that we have this little square, and this means this is a right triangle. So we can use the trigonometric ratios in any right triangle. So I'm going to use this SOHCAHTOA. We have to determine the side lengths x as well as the hypotenuse y. So first, I'm going to use this tangent ratio using the TOA from SOHCAHTOA. That is, I see that this angle is 30 degree. So I'm going to find the tangent of 30 degree. And this equals, according to this SOHCAHTOA, it is opposite side over adjacent side. The opposite side to angle 30 degree is ND. So this is the opposite side, and over adjacent side is LD. Now let's replace ND. This is indicated by X, and we know that segment or the leg LD is 40. So we have tangent of 30 equals X over 40. And I'm going to multiply both sides by 40. So we get 40 times tangent of 30 degree. This equals 6. I'm sorry, x. So we can now plug this value into the calculator. Let me do that. So I plug in 40 times tangent of 30. And when I do that, I get 23.09. So we can see that x is approximately 23.09. Now let's see how to determine this unknown side length y. For this, we can either use sine ratio or the cosine ratio. Here, I'm going to use the cosine ratio, that is using the co in SOHCAHTOA. So I write down cosine of the angle 30 degree, that is cosine 30 degree, and this equals adjacent side. The adjacent side to cosine 30 degree is LD. So we put LD divided by hypotenuse is ln. Now let's me replace LD by 40 because we know that the segment LD is 40. In fact, this is leg LD, which is 40, and ln, which is the hypotenuse. This is indicated by the letter y. So we have this equation: cosine of 30 degree equals 40 over y. Now let me cross multiply, or I just multiply both sides by y, so that I get y times of cos 30 degree, and this equals 40. Now since we have to solve by y, we can divide both sides by 30 degree, cos of 30 degree. So I do like this, that is y times of cos of 30 degree. We divide by the cos of 30 degree, and this equals 40 divided by cos of 30 degree. We can cancel this cosine of 30 degree like this and like this. So we get y equals 40 over cosine of 30 degree. Now let's plug this into the calculator. So I put 40 divided by cosine of 30 degree, and this equals 46.18. So this is approximately, when rounded to two decimal places, it is 46.19. So y we are getting as 46 point. This is approximately 46.19.